Sorry for the delay, by the way. Thank you all for coming to this session. So my name is Hüseyin. In this session, I will provide to you a set of best practices about how to maintain open source Go projects. So here, whatever you see, they are all applicable to other languages, but the examples, they are specifically provided in Go. Examples are in Go. But you are free to apply these methodologies in any kind of other languages. Of course, not something like assembly or some other languages, but you can apply to some modern languages. First of all, I would like to start with I am really happy to use GitHub, GitLab, and Bitbucket because they really enable the developer ecosystem in a way that we will collaborate in good projects, right? So open source project, open source world, always there before the GitHub, but they somehow shape this world and put into very good situation. And so you have a project, lots of people, lots of contributors working on that. That's a very cool thing, but of course it has some kind of drawbacks. First of all, you need to introduce some kind of rules in order to keep this project quality on track. In this session, we will mostly see how to do that, how to automate this process. First of all, let's start with Go project structure. I will not deep dive into Go internals because if you want to see the Go internals at the end of the session, I will provide a link and you can see the session titled by Fast Track to Golang Development. You can see all the best practices there. But here, I assume that you have a project, open source project. It is a modular project, which is called, you can do that with Go modules. In order to create a modular project, you can do go mod init and provide your version control system URL. Here, it can be GitHub, GitLab, or Bitbucket, whatever you want. When you do that, you will see it will generate a mod file, go.mod. It is really same with, the notation is similar with Node.js and npm init. It creates a package JSON. It contains some kind of metadata, version, dependencies. Same strategy is here. When you have a look at the details in Go mod file, you will see the module name, actually the URL, and the Go version that is used to build, compile for this project. And also you can see the dependencies. Dependencies are stated by using require keyword. In require keyword, you can use one or multiple dependencies. In my case, I am using Go SDK for GitHub APIs, and that's it. So again, in order to see your dependencies, for example, in Java, if you are using Maven, you can just create a tree by using Maven dependency tree and output it to a file. You will see the hierarchy of the dependencies. Here, there is same strategy. You can list the dependencies. Of course, these dependencies can be direct and indirect dependencies. In my case, I only use Go GitHub, but you see there are 10 more dependencies because Go GitHub just relays on the other packages that are not indirect dependencies for me. So using Go module project, Go module system will be a plus for you. It will be a plus for your start. Okay. PRs are very important in this kind of community project. If it is an open source project, most probably you will use a PR notation, GitHub PR flow. If you are inside your, how can I say that, in your company, for the internal projects, you can use maybe trunk-based development. But here in the community, using the GitHub PR flow will be best because it is the quality gate for your project. Let's say that you have an idea. There is a feature needs to be implemented. You fire a feature branch, you implement your stuff, whatever the feature it is, you push the remove, and you create a PR, right? When you create this PR, there should be some kind of set of checks inside this PR to understand that, okay, I am on track with my quality, everything works. If you added new features, then you need to cover that new lines. And based on this information, you can see that there are three categories in this kind of PR checks. First one, linters, vulnerability checks, and the code coverage. Linters is something like help you to keep your code base as qualified as possible. And you can use linter libraries, for example, govet, aircheck, structcheck, varcheck, for example, this kind of dead code. There are this kind of libraries. You can use them independently. Or there is a better option, which is Golang CI lint. This is the complete orchestrator of different kind of linters. So instead of using linters separately, I mean trying to download them separately, you can use Golang CI lint, provide your configuration, and run it. That's it. It is something like test runner for your maybe Maven JUnit run, something like JUnit runner, Gradle test runner, or some test suite in Go or Node.js related technologies. If I provide you a couple of examples about these linters, for example, Aircheck in Golang, if you use a function and let's say that it returns an error after this function execution, if you do not handle this error, you will see it will generate a warning for you if you use Aircheck a linter. That code, most probably you see this in your IDE. So if there is an unreachable code, you will get set of warnings produced by this dead code linter check. Struct check, again, there are different kind of checks on these structs. You know, structs are very important term in Go. And let's say that there is a struct, you export 5 fields out of this struct and you never use them. So you will see some kind of warnings. Okay, you have struct fields, they are capitalized, they are exposed to outside, but you never use them. Maybe you can make it private, right? Govet, it is some kind of basic static code analysis for your Go projects. You can use this tool independently, and also you can use it within the Golang CI lint runner. Varcheck, as you can understand, if you define a variable and never use it, you will see a couple of warnings on your terminal. Usage is very easy. You can just download it, install this Golang CI lint in your workstation machine, whatever, terminal, computer, VM, whatever it is, and you can run it by Golang CI lint run. That's it. It will first have a look at if there is a configuration. If there is a configuration, it will, how can I say that, the configure its internal configuration based on your file. If there is no file, it will use the default values. That's it. And this is a simple output of Golang CI lint run. I said that -- enable all. That means it will use all the linters exist in this, how can I say that, set. And you see on not only the errors, warnings, but there is a good property here. I said enable all, but you see interfacers, scope lint, melint, golint. Actually, they are deprecated, and you see it says the repository of the linter has been archived by the owner. This is very good information, I think. So you depend on a project, but actually it is archived. So it can be dangerous, right? I mean, there is no maintenance of that. You are saying that, okay, I am using scope lint and I am safe. No, you are not safe. You see it is being archived, and somehow you need to change this library and depend on another one. Maybe you can voluntarily just hand over this project and continue to maintain it, right? And one example here about linter check, you see by default in linter, it comes from one of the linter, funlen, function len. It is one of the anti-patterns in all of the languages. In Go, it is defined something like 40. If you have a function, it should be at most, contains at most 40 lines. If you have 41, as in my case, you see I got this error. If you have more than 40 lines, then it seems that you need to extract this logic to some other set of sub-functions to do that. This is in my terminal, but of course, it should be automated in a different way. We will see it. Okay, the second part, vulnerability check. Especially you see nowadays, last 1 week, you see Log4j everywhere, right? And these vulnerability checks are also important for your code base, because by using linters, you can have very, very basic set of security checks but you cannot trust on them at all. In order to do this in a, let's say that apply the best practice, you need to have something dedicated to this domain. And I can suggest you a tool which is called Codeql. And it is really good option for automation environment. If you do this manually, you will see it will have Codeql database create. Here, what you say, go to the root of your project, create a database, provide your folder, of course, and specify the language. If you specify language, this analysis tool will do the analysis or create a database based on your language specified. That's it. And after create your database, you can analyze it. When you analyzing means, okay, get database, analyze, maybe you can generate some kind of report out of that. And of course, the best practice for this to use it GitHub Actions. You can do that manually. Of course, before the GitHub, this was done manually, but now you have chance to execute this within the GitHub Actions. The third step is the code coverage. In code coverage, running tests in Go is very simple. There is a naming conventions in Go. So if you create a test file and name your function starting with test, you will see they will be all detected as a test suites by using Go test command. If you provide the -cover option, you will see it will also calculate the coverage. When you provide cover profile output file, the coverage information will be put inside this file. And you see the output in the terminal. It says in Fibonacci, Fibonacci folder, we have 100% coverage, but on the other files, there are no tests at all. So Hüseyin, where can we use this output file, coverage out? So why we are generating this? We are generating because there are some set of tools that gets this coverage file and generates a report. You know, if there are Java developers here, you remember Jacopo exec files, right? Same strategy, very same. And I am using CodeClimate for my open source project. And once you use it, you will see when you create your PR, there will be this code coverage step in my GitHub Actions. And by doing this output file is passed to the CodeClimate execution, and they know how to build a UI based on this output coverage file. So you see there are 62 is not covered by my tests, but the other files are already covered with my test. That's it. So until this point, the main reason was to keep quality for my project code base. This is very important because it is very important because when you increase your team member size in this project, let's say the contributors, it will be a bit hard to maintain at all if you do not keep this quality as well. And of course, let's say that you are a contributor, you check the open source project. Oh, this is a nasty code base, so I cannot involve in this project. So this is very bad for your reputation, right? So that's why you need to use this kind of quality gate checks. So about distribution, let's say that you have the cleanest code base in the world. If you do not provide a proper distribution channel, then you will see it will not good, because I am a Mac user, there are Windows user, they are using some kind of, they want to build this project from source code. Maybe they need Docker images, etc. So you need to somehow provide this kind of binaries so that it will be very easy for other developers to download and use it in a plug and play notation. First of all, Golang has a very good advantage on this building binaries, right? Right after you build binary, you can continue with the Docker image step. And then, of course, maybe for the quick insight, you can introduce these badges in your open source project. First of all, let's focus on the executable binary section. For executable binaries, what we do, Go is a very good language to compile some source code into an executable binary. So it is supported by default. First of all, you need to understand your environment. go to this list. When you do this command, you will see the table of supported operating system and architecture pair. Here, for example, Darwin is my operating system, AMD 64 is my architecture, right? The CPU architecture. And based on this information, before you say go build, you can define your environment variables. For example, go operating system is Darwin, go architecture is AMD 64. So based on this information, this go build command will produce a binary for you that is supported by, that is suitable for Mac and AMD 64 CPU architecture. That's it. In GitHub Actions, there are a good feature which is matrix build, so you can provide as much as value here, and same build operation will be executed for this pair. So you can generate this build by using different set of parameters. I mean, operating system and the CPU architecture. Okay, when you generate your binary, and it will be very easy for you to generate Docker images. So in Docker generation phase, you can create a Docker file, and then you can use multi-stage build. I am saying multi-stage build because since I have an executable, I can provide this executable into any kind of Docker image as an entry point, right? So let's say that you have a Linux machine, you are about to start it. The only thing it needs just an entry point process. You remember this grub2 processes for your Linux distributions. And here in the first stage, I am saying that I am using Golang Alpine distribution for my Docker image. I create a folder which is called USR SRC app, and I copy all the source code to this folder. I download the dependencies by using gomod download, and then I build my executable, which is called hello in this case, and my operating system is Linux in this case. So I generated my binary in first phase, and now first stage, and now it is time to switch to second stage. In second stage, I am using a totally different Docker image, which is from scratch. Scratch is something like zero size Docker image, and there is nothing inside it. And I use zero size Docker image, and I copy my already generated binary from the first stage, which is builder. You can refer the first line. The alias is builder for the Golang image. And I copy this one from first folder to second folder, which is on the second stage. I provide this hello binary as an entry point to Scratch image, Docker image, and I expose 8080 to outside because most probably I serve my application through the 8080 port. That's it. So instead of having your Golang dependency, even in the runtime, because you don't need to have Golang dependency in your runtime, right? Because Golang can be a binary, and you can just execute a binary. You don't need to include Golang in the entire Docker image. In the second stage, we have only Scratch and the binary. Most probably you will have something like 1 megabyte, not 1 megabyte, but 2 megabyte image, but based on your dependency. If you have AWS SDK, kubectl, Kubernetes Go SDK dependency, this kind of libraries, you will see it will be increased a bit. But at the end, you can have something like 2 megabyte, 3 megabyte, and 4 megabyte images at the end. You see how portable it is. So especially within this kind of distributed environments, you have microservices. Each service has, let's say, that 5 replicas. So 6 megabyte Docker image, and it will be scaled automatically, very easy. Project badges. Project badges are very important because it really provides a quick insight about your project. When you open your README, you will see, okay, this is a Go project. Okay, when I click Go reference, I can see the Go doc. I can see the report for this project, maintainability score, test coverage. Even I can see the Docker image version. When I click on it, you will see it will redirect you to the Docker Hub, on my case, to see the Docker image for this project. And I mostly use Shield.io. Shield.io is something like project badge as a service. You can go there, search for any badge, for example, Docker image, test coverage, code climate, Stack Overflow. There are lots of badges there. you can provide your parameter. It can be user ID, GitHub repo name, Stack Overflow user ID, something like this. It can generate a badge for you, provide a full URL. You can just import this URL into your README file within a markdown notation. Also, you have another option, which is if you are using GitHub Actions, you can generate these badges within your GitHub Action job execution. So you have two options, maybe Shield.io, and you can use GitHub Action for this. So we are talking about the artifact generation. We are talking about artifact generation, but what about making it more easy? So in order to distribute your this artifact, you can use Go Releaser. Go Releaser is a very good tool to especially ship your product into any kind of destination. It can be Docker image, Brew, something like that. Even you can announce your releases within Discord, Slack, and Twitter. So Go Releaser has support cross-compile projects. So you can do a cross-compile because it is supported by Go. And you can release this one to GitHub, GitLab, and GitHub if you want. Releasing means when you release something by Go Releaser, you will see it will create a release on your GitHub project. You know, when you go to the tags, you will see the separate tab, which is called release. When you click on that release, you will see some kind of changelog. You will see some kind of attached assets. It can be source code. It can be binary, Docker image link, etc. You can generate Docker images on the fly. So you can ship your Docker image in any kind of destination. And you can come up with a manifest. So let's say that you build a Docker image. You can tag it as latest and maybe tag it like 1.2.3. So it is a well-known best practice. Whenever you generate a Docker image, you can always tag it with the current version. Plus, you can tag it as latest. So you always update latest tag in the Docker Hub, and always you can tag the current version. That's it. You can ship this artifact to Brew, and also for the Mac users, they can download this dependency from the Brew, and you can announce this release to Slack, Discord, and Twitter automatically. So it is an end-to-end solution for your, how can I say that, product feature or tag or release operation. If you are using GitHub, I really suggest you to use GitHub Actions because everything is there. You don't need to do anything manual. For example, in the past, I was using some kind of Travis CI, Circle CI, this kind of tools for my build operations and do integration tests. But nowadays, I don't need them because everything is there in GitHub Action. Whatever I need, I search on the marketplace and I see everything. So, for example, for Golang CI lint, there is a GitHub action for this. Just include it, provide parameters, and that's it. It really simplifies your flows, and Codeql, Codeql linter, artifact generation, they are all available in GitHub Action. You can see the examples for that. Dependency maintenance. So you can think that it can be related to security, but also it can be related to linters because there is a new version. Maybe there is a performance improvements. There can be some kind of security improvements. You don't know that, right? But I am using Dependabot for this. Most probably you have heard this. There is a seamless integration with GitHub inside it. So in this part, Dependabot integration, you can use Dependabot YAML configuration, and that's it. So we will see an example, by the way, but when you integrate Dependabot, it will start to maintain your dependencies. So I am using, for example, Kubernetes Go module, and it warns me about, okay, you are using 0.22.3, but you can upgrade it to 0.23.1. And you can click on commit to see what is the change logs. And then, yeah, if you want, you can merge it. So Dependabot is responsible for checking the dependency continuously, and then it just prepares a PR for you. The only thing you need to do is just check and merge the PR. That's it. Of course, it cannot be so that easy. For example, you can, so even you don't have a compile time problems, or your test coverages are okay, there is no security related problems, but you need to be on the safe side by doing end-to-end test. So let's say that I upgraded my Spring Boot version because Dependabot just suggested me to do that. But when I run this application, I see, oh, there is a problem. Application is not running. It is running, started, but the functionality is broken. Why? Because from Spring Boot 2.2 to 2.3, when I upgraded, they changed the default content encoding. I mean, the content type. So it really break everything. So you need to somehow do end-to-end test. That's why these GitHub PR checks are really important for this kind of operations. But most probably, if you have, sorry, what is this? We can say that there is a minor change. There is no major change, right? The first digit is not changed. I can say that there is no major change, and I can freely upgrade this. But this semantic versioning is not something applied very well for all the projects. Even they introduce a major change, they can, when I have a look at the version, I see that there is no major change. But I don't know how maintainer works this with semantic versioning. Maybe they introduce major change, but incremented their minor version part. So to be on the safe side, just use the end-to-end test. So for the theoretical information, that was all. And I will show you a couple of examples for all of the theoretical topics. If you have any kind of questions, you can ask them, and in an async way, we can answer the questions. Okay, so let me switch to the example. So I just wanted to start with Golang CI lint part. So I assume you see my screen well. Okay, here, first of all, when I open this project, we can analyze a couple of more projects, of course, but to be on the safe side, I just wanted to show them my examples. So when I open this project, you see there are some kind of badges, right? When you click on this, you can see the Docker image, but this is not actually a link. Okay, and this is code climate. When you click on the, for example, code climate, you can see the actual code. You can see the code coverage. For example, here it lists all the files. And when this column is for coverage, test coverage. And when I click on this line, where are you? Source and coverage. So I can see which lines are covered and which lines are not. So this is an example of how we are using these badges. When you click on Go reference, you will see it will go to the Go doc. So go here and see the actual documentation without cloning the project. Or if you are using a tool, something like Dash, which is a very good tool for documentation, you can just import there and see everything inside it. Okay, so let's have a look at this part. Whatever you have for GitHub action, you will see they are called workflows, right? GitHub workflows, and Dependabot has a special integration. So normally my integrations are here under the workflow. This is a special folder, by the way, known by GitHub itself. But Dependabot has something different, special integration. So that's why we have Dependabot in the root. Here, when you have a look at this part, I have only two configuration. First one is Go mode. That means, okay, Dependabot, could you please analyze my dependencies? Just check them. I am using Go mode. This is the Go mode notation. And my directory is the root folder. And do this daily, please. So Dependabot checks my dependencies daily, and it creates PRs once needed, right? And also, my source code is okay, but do we really trust this GitHub folder? So what about this? Can you see my screen right now? Well, okay. So I am saying that, okay, dependabot, could you please track my dependency? I am using Go mode. But what about this GitHub action? I need to track also GitHub action, because GitHub action means you can use some kind of built-in features, but at the same time, you are using some kind of open source GitHub actions, the community maintained GitHub actions. So also I am saying that just track the dependencies for GitHub actions also. My root folder is this one, do that with daily. So if you are using Golang CI lint runner GitHub action, and this dependabot will also check the dependency for that GitHub action. GitHub action means it can be written in TypeScript and other language or whatever it is, but it will track it for you. Very good methodology. And when I check workflows, you see I have continuous integration. It contains this linter stuff, code coverage. I have Docker image generation, and also I have vulnerability scanning. When I check continuous integration, here it is triggered by when I merge something into main branch, plus whenever you create a pull request against main branch, these jobs will be executed in order. So first of all, we check out the project. I say that, okay, I am using 118 for my Go projects. And then I am saying that, could you please execute Golang CI lint runner on this part? And timeout is 15 minutes. That means it may take some time to time. So I am saying that in 15 minutes, if it is not finished, just fail the job. And after that, you see it also executes code coverage, and there is a code coverage out file. And this test coverage step knows how to handle this coverage, because I am using Codeql, and this is my reporter ID. This is not a confidential information, by the way. Since it is an open source project, you can also go to that Codeql in order to see my results. I mean, here, this coverage file test coverage produces something. Codeql uses this file to generate the report. That's it. So for this file, yeah, I will show a couple of examples there. There is a manual Docker image generation here, but I will use the better solution on another project. But here, what I do is, whenever you tag this project, it gets the release version from your Git information. I log into Docker Hub, this Docker username and token. Of course, never provide a credential confidential data in your GitHub action file. Just create a secret in GitHub and fetch it from the secrets notation here. Secrets, Docker Hub username and token. And after that, I build and push it to the Docker Hub in a way that Hüseyin Babal demory and version. This is the manual version. And finally, the vulnerability scanning. As I already said, whenever you create a pull request or whenever you merge it to main branch, this vulnerability scanning will be executed. So I use 117, and I am using Codeql GitHub action. So if you are using GitHub action, everything becomes simpler. I am saying that just use language Go and Codeql analysis. It just creates the database and analyze the database. That's it. Let me show you a couple of action job execution result. So here, this is one of the execution here. Build, test, and coverage. When I click, when you have a look at it, you will see the stages: setup, checkout, use. For example, there is a linter here. The linter job is executed, and there is no, let's say that, findings. There's no findings. And we do test coverage here, test coverage information, as you can see here. And there is some kind of coverage here, and test report uploaded to Codeql successfully. What else? In GitHub Actions, we can also see vulnerability scanning. In vulnerability scanning, Codeql, and it initializes Codeql. As you can see here, it creates skeleton Codeql database, and it analyzes it and extracting the information from this. If there is a failure, it will report, it will fail your job. So that is the main idea. And when I check pull request, you will see a couple of lots of, how can I say that, dependable stuff. For example, there is API, client Go, API machinery, etc. So let me go to the client Go here. This is generated by Dependabot. You can see the commits here, what is inside it. So Dependabot is very good on this. It generates lots of useful change logs for you. So I can say that this is okay for me. Let's merge this one. Delete branch. There is some certain comments here. Okay, Dependabot create. Okay. And when I go to pull requests, right, there are a couple of pull requests here. I just wanted to see if they are still valid or not. In order to refresh them, when I say Dependabot create, it will say, okay, I will handle it. You see, I added this comment and Dependabot says me, okay, I will handle it. So most probably it will, rebasing this part. Okay, most probably it will reduce the PRs. You see, it was 5 and it is reduced to 4. Why? Because I already merged something and it deprecated one of the previous PRs. So it's really cool. You can have a look and see what is there, what are their options. And finally, I just wanted to show you about Go Releaser. This is very cool project. And here there is almost zero configuration. In release YAML, I am using this. This is a hypervisor emulator, by the way. So because since we are generating some artifacts based on different architecture operating system, this Chemo project is something for that, hypervisor. So it simulates these architectures and underlying operating systems. I log into Docker here, and Docker login plugin, but actually I am logging to GitHub's own container registry. This is GitHub container registry. I am the owner, so you can get these predefined variables, set up Go, and run Go release action again. So it generates all the packages. It releases it to destination with this GitHub action, a GitHub container registry on this case, and that's it. So let me check if there's a configuration here. Yeah, Go releaser YAML, this one. And here I basically define my parameter. This I have a separate session for this. Again, you can go to my profile and check the related session. And this is for specifying how to generate your artifacts, including the Docker executable, and how to generate your Docker manifest. So on my case, I am building, let's see the outputs one of these, and you will better understand it. One of the output of this one. Yeah, Go releaser. You see, it tags this project as 008 because this is my final tag, git tag, and also it pushes this one as a latest. So whenever you introduce new tag, it will generate a Docker image based on that tag, tag it, push it to GitHub container registry, and also it will tag as a latest to keep latest tag as up to date. And when we have a look at this releases page here, releases, you see it is automatically created by Go releaser. When you have a look at that, there is a commit history change log. You can see the Docker image, how to pull Docker image here, and you can see all the artifacts are attached here. Tars files, some AMD 64 zip, TARDZ. So you don't need to think about this process. So if you have this kind of Go projects, just use Go releaser. This is specifically for Go projects. So that's all, by the way, all theoretical, and I hope this demo also was very useful for you. And I think we are